So people ask for help with the homework on dilations, so let's go through the homework on dilations. Perimeter and area. So start off, gives us two shapes. It says for each pair of similar figures, determine the perimeter of the second figure. Okay, grab a pen here. So we have this triangle with a side of 12 going to this shape with a side of 18. Okay, so it's getting bigger. Doesn't tell us what the scale factor is. So first thing we have to do is we've got to calculate scale factor. Since it's getting bigger, we know it has to be greater than 1. So when we divide this, we need to divide it in such a way that we get a number greater than 1, which means the bigger number's got to go on top. So it's going to be 18 divided by 12, which if we work that out will give us a scale factor of 1.5, which is definitely greater than 1. Once we know the scale factor, since we're just looking for perimeter, we said for little formula was our new perimeter will always be equal to the original times the scale factor. So our original perimeter was 38 times our scale factor of 1.5, and that will give us, make sure I type this in so I don't get it wrong, 38 times 1.5. Oh, okay, well, calculator's not working right. 57. Okay, just making sure. So our perimeter here is 57 millimeters. And that's all there is to it. So it's the same thing for number 2. So we have 8.4, 6.3. Okay. So our scale factor is going to be equal to, this time it's getting smaller, which means we need a scale factor that's less than 1. So again, it's going to be the new over the original, right? Because a proper fraction will give us something less than 1. In this case, if we work it out, it comes out to exactly 0.75. And that's still perimeter, so our formula is still the new is equal to the original times our scale factor. So that gives us 19.4 times 0.75. And that is, let's see, 14.55. Okay, so there's our first two answers. Nothing too painful. Alright, number 3, so we get the word problems. City of Bryce, planning both skate park, architecture designed it at the right. Okay, so here's our plan. So it was 25 inches is our width there. The perimeter of this park is 80, so we can say P equals 80. The actual length of WX is 50 feet. Okay, so if we had our second shape, another rectangle, perfect. WX, just the side up here, is actually 50 feet. Okay, and then what will be the perimeter of the actual skate park? So now once we have this set up, which I did for you, now it's just like these first two problems. So you find your scale factor and then multiply by the original. Okay, so I'll let you figure that one out. I don't want to do everything for you. Number 4, child's desk is made so that the dimensions are 2/3 the dimensions of a full-size desk. Okay, so we can draw ourselves two desks here. Let me see. And a second desk. There we go. Okay. Thought that would make shapes for me, but it didn't. So we can say this is our kid desk, this is our adult desk. So the full-size desk is 54, and that's the top of it, 54 long. Okay, so that's the dimensions, 54 by 36. And then it's 2/3. So our scale factor is 2/3, right? Where did I read that? 2/3. We wrote this down. What is the perimeter and area of the top of the child's desk? Okay, so this, I guess, I did my picture kind of backwards here, because now we're going from the adult back down to the kid size, right? So to find our new dimensions, we just multiply, right? Same as perimeter. We say, what is this side times 2/3? And then this side times 2/3. So if we wanted to put this in the calculator, like say you don't have your graphing calculator, we can set this up. Let me write this down. So 36 times 2/3. So what we do is we say 36 times 2, right? Multiply across, equals whatever we get, then we divide that by 3. So that'll give us 24. This side over here. Then we do the same thing for 54. So we'd say 54 times 2 divided by 3. So if you have a good graphing calculator, it'll do all that at once, but if you don't, if you just have something real basic, that'll work for you. Okay, so our new dimensions are 24 by 36, and then it wants the perimeter and area. So at this point, since I found the dimensions, I don't actually need this anymore. Now this is just what's perimeter and area. So perimeter would be 24 plus 36 plus 24 plus 36, whatever that works out to. And then area, since it's a rectangle, just base times height, is just 36 times 24. So you throw that in your calculator, you get your answers. But you do need both answers. So perimeter equals some number of inches, and area equals some number of inches squared. Okay? Alright, now let's do this last one, which I think we may have done together. I don't know. Here it is again. Theo's making a putting green in his backyard, wants to be similar to the one at the local golf course, but 1/3 the dimensions. The area of the original is 1,134 square feet. And what will be the area? So there's all the information we need. So we know scale factor is 1/3. Okay. The original is 1134, and we're looking for area. So if we're wanting to solve for area, it's a lot like perimeter. The new area equals the original area, but instead of just times scale factor, since area is in 2 dimensions, right, it's scale factor to the second power. So we have 1134 times, and then it's in parentheses, 1/3 squared. Okay, so if you put all this into a good enough calculator, it'll give you your answer right away. But let's say again we don't have a good calculator, so we need to do this sort of by hand. So 1/3 squared is the same as 1/3 times 1/3, and that's math we can do, right? 1 times 1 is 1. 3 times 3, not 6, but 9. So 1/3 squared is just 1/9. And then we can bring this down. So you have 1134 times 1/9. So that would look like 1134. Now times 1, you could do this to follow the same pattern we did here, but anything times 1 is just itself. So a little bit unnecessary, but you can do it if you really want to. And then divided by our fraction here, our denominator. And that gives us 126. So our new area would be 126, and that's square feet. Let's see, 126 feet squared. And then we could check this if we work backwards, right? If this is 1/9 the size of the original, if we were to say 126 times 9, we should get 1134. So we know we did it correctly. Also because we have a calculator, and the calculator doesn't make math mistakes. So there it is. 2 formulas that you need to remember. Let's see, I have a highlighter here I can use. There it is. So nu equals original times scale factor. That's if we're finding perimeter or just side lengths, that works. And then if we're looking for area, or later on this year, if we're doing surface area, it's original times scale factor squared. So if you can remember those, do just fine. Alright, that's it.